Assalamualaikum and hi, welcome back to chapter 4. Okay, so on the previous video, we have learned a few properties on a transpose matrix. So we have shown the first properties here, okay, and by the second properties here, if we transpose matrix A and then we transpose it back, it will be a matrix A itself. So this one, I think you can try it on your own for matrix second properties. For the third properties, we have tried the example as well. So we have shown that the product of A, B, and then we transpose them is equals to finding B transpose multiplied by A transpose. Okay, the fourth properties here is related to the third properties. So note that A, B transpose is not equal to A transpose multiplied by B transpose. So we need to remember this one. Okay, and then for the fifth properties, K multiplied by a matrix A and then we transpose it will be the same as we transpose the matrix A first and then multiply by the scalar K. Alright, now the last two properties, we are going to look at the examples. Okay. It is about a symmetrical matrix and a skew symmetrical matrix. Okay, so I have explained all these five. Okay, so now let's try example 4 part B. Show that the matrix A is a skew symmetrical matrix. So what is a skew symmetrical matrix? So in these properties number 7, if A is a square matrix and A is negative of A transpose, then A is a skew symmetrical matrix. So we need to show that A is equals to negative of A transpose. So since matrix A is already given in the question, so let us try to find the negative of A transpose. So we can either multiply negative 1 with matrix A and then we transpose it later, or we can transpose first the matrix A and then multiply by the negative sign. So you can do either one. Okay, first let me write the matrix. Okay, so what I am going to do, I'm going to multiply by negative sign first and then I'm going to transpose it later. So multiply by the negative. And next, I am going to transpose the matrix. So let me write it here. So the first row will become the first column, 0, negative 2, 1. And then the second row will become the second column, 2, 0, 3. And lastly, the third row, the third column, negative 1, negative 3, 0. So I hope you already mastered this one, the transpose matrix. Okay, so this will be the final answer. So as we can see, the final answer is actually the same as the original matrix, which is matrix A. So we can say that A is a skew symmetrical matrix. Since A is equals to the negative of A transpose. Okay, so that will be the conclusion from part B. Now, the last one, part C. Show that matrix M is a symmetrical matrix. Okay, so by referring to the properties number 6, okay, in this green bubble, if A if A is a square matrix and A is equals to A transpose itself, then A is a symmetric matrix. Okay, means A is actually the transpose of itself. Okay, so actually we can see the diagonal here. So even if we transpose it, it will be the same. Okay, so M transpose is equal to 1, 2, 2, 3. Okay, now we transpose the matrix. The first row will become the first column. So 1, 2 here, and then 2, 3 will become the second column. Okay, so since we already know that, since we already see that it is actually matrix M, so therefore matrix M is a symmetrical matrix. Okay, let me add this up, since M is equals to the transpose of matrix M. Okay, so that's all for this video. So see you next time. Thank you and bye bye.